So this next video is looking at calculating areas above and below the x-axis. So just basically speaking, the area above the curve, above the x-axis is when the derivative function is positive. So imagine a positive velocity. That's going to give us positive area or positive displacement. If the derivative function is below the x-axis, it means we have a negative derivative or a negative velocity, and the displacement or the area would then be negative. So that's what we've done here. Okay, so if f prime is positive, if that derivative function is positive, we end up with a positive antiderivative displacement, and if f prime is negative, we get a negative antiderivative displacement. Okay, so we're taking a look at, we're going to find the area between the x-axis and the curve of y equals 9x minus x cubed. So we should sketch the function. Okay, so this has zeros at, it looks like 3 and 3, okay, and 0. So this is going to be a negative polycubic function. It looks like that. Okay, and so we're looking at, looks like it is symmetrical. So we can actually probably figure out the net displacement just by looking at it by inspection. So the net displacement from -3 to 3, if we look at this, the area above the curve here and the area below the curve here, based on the symmetry of the graph, we should expect it to be 0. Okay, so that's because it should be the net displacement. So let's check this out. We're going to calculate the area, and we're going to use a fundamental theorem of calculus in that the area under the curve is equivalent to the displacement on the antiderivative of the original function. Okay, so we're going to anti-differentiate this. So we end up with 9x squared over 2 minus x4 over 4, and we're going to calculate from -3 to 3. Okay, so plugging that in, we end up with 9 times 3 squared over 2 minus 3 to the power 4 over 4 minus, and we end up with 9 times -3 squared over 2. Well, those are going to cancel out. Okay, and then minus, it's going to be -3 to the power 4 over 4. Again, those will cancel out. That's going to be equivalent to that. They will cancel each other out. And so we end up with a net displacement of 0. Okay, so that is the net displacement, or the area when we calculate the area above and the area below. Now, if we wanted to calculate the area, we'd have to split this up because we want this area and this area to be calculated separately, not work against each other or cancel each other out. Okay, so it's important to make sure you understand the distinction. When are we looking at net displacement, where the negative area counts against the positive area, or when we're talking about area? So in this case, the questions are asking about net displacement. So we're just going to worry about the antiderivative and just plug into the antiderivative. Yeah, no problem. They cancel out, and that's what we expect. So taking a look at this next function here, it looks like we have a 0 at 2, and looks like there's a bounce at 0. Looks like it's a positive leading coefficient, so I would expect the graph to look something like that. Okay, so there's at 2, 3 is somewhere around here. So again, we have part of the curve above the x-axis and part of the curve below the x-axis. Okay, so we want not the area, so we're not going to split these up into 2 different parts. We want the negative area to count against the positive area because we want to calculate the net displacement. So I'm going to find out here. So the change in big F is equal to the derivative function, the area under the derivative function from 0 to 3. Okay, so that's the change. So delta big F. So again, we're going to use the fundamental theorem of calculus says then that the area under these curves is going to be equivalent to the net displacement between the starting point and ending point on the antiderivative function. So again, I'm going to anti-differentiate this. And I'm going to calculate this from 0 to 3. Plugging in, I end up with 3 to the power 4 over 4 minus 2 times 3 to the power 3 over 3 minus, and that's just all going to end up being 0 when I plug in 0. So I end up with 81 over 4 minus, the 3's are going to cancel out. So I end up with 9 times 2 is 18. Okay, when I simplify this, it's going to be 20 and 1/4 minus 18, so I'm going to get 2 and 1/4. I'll leave that as an improper fraction as 9/4. Okay, so the net displacement from 0 to 3 is going to equal 2.25 net displacement, whatever that would be. And that would be the positive area counted against the negative